After watching this video, SQL joins won't be confusing anymore. To perform a SQL join, start by choosing a join condition. This is how we connect the tables. Later in the video, we explore different join types, like outer joins and inner joins, which determine how the combined tables create our final result. The first join condition is called natural. This just means that we combine our table by the same named attributes, which is kinda the most natural way of joining a couple tables if you think about it. Attributes are just another name for columns, by the way. The idea is that, for every row in the left table, we connect it with every row in the right table that has the same values for each same named attribute. In our example, we have a person table with a person ID and name. We also have an eats table with a person ID and the number of calories that they eat. The attribute that both tables share is the ID attribute, so we will match rows from table 1 with rows from table 2 that have the same ID value. We will merge the ID attribute into one column, which we have highlighted in blue, because that is the attribute we are joining on. It is safe to merge them because we will only get a match for an ID if it has the same value and we know they have the same attribute name. We also add each attribute that is unique to their own respective table. Let's find every match for the first row of the person table. It matches the first row because they both have an ID of 1. We can fill in the first row of our join table using the matches value. First, we add the value from both our ID attributes from our two tables into our merged ID attribute. We can then fill in the values for our uniquely named attributes. We now look for other matches for the first row of table 1, but there are no more matches. Now, we look for matches on the second row of the person table. We don't match the first row of table 2, but we do match row 2, so we add in our values for the match. And look, we got another match for our second row in the person table, so we add in our values. We don't need to keep going because it is clear that we matched all the 2s. And our ID of 3 in table 1 does not have any matches by ID in the second table. This means we have our join table by the natural join condition. Now, I will pass things over to Andrew to discuss the last two types of join conditions.
Now, let's consider a different case. Notice that there are two attributes matching here, so we must join the table based on ID and name. We will get any empty table after the join, because no players have the same name as any of the food items. We can resolve this by using the join condition. This join condition works exactly the same as the natural join, except we specify the same named attributes that we want to join by. We can't specify calories or weight, because they don't have a same name attribute in the other table being joined. Let's do a using with ID specified. Then we would get 3 matches with all possible rows that can give a player and one of their eating record. Now, let's get more flexible with our joins. We just use predicates with the on-join condition. If the join condition predicate is true, then the matching rows are concatenated. Please note that we don't merge same-named attributes into the join table, because we are simply joining based on whether a predicate is true or false. If we did a predicate for calories is greater than 200, then we would get 3 matches. We can insert each match in now, where each player matches the row for an apple. If we did a predicate for calories is greater than 200 and player ID equals eats ID, then we would only get 1 match for Jim and the apple. Now, one question that oftentimes comes up is if where and on do the same thing. They don't. The on keyword actually decides what is joined before running where. The where clause filters the result of the join after the joining of the tables. The highlighted rows here are not matched on a join condition using ID, but they can be included using an outer join, which is a special join that includes rows from a table where the row did not meet the join requirement. This can't happen if we try to do the join using a where clause, because it won't be lenient like the outer join. Even if you don't use an outer join, joins are more readable if you use a join condition rather than a where clause. If we run this left join, it includes our unmatched rows from the left table. If we run this left outer join, that includes the unmatched row in the left table, but try to join based on the where clause, that the where clause, which runs after the joins, will remove Jin from our result. Thanks for watching. Hop on SQLGuild.com for SQL coding challenges and lessons.
Now, we are ready to do our joins. First, let's quickly make sure we understand the syntax of the join conditions. We just place the keyword natural before the join keyword if we use a natural join condition. If we use using or on, then we wait until after we have written our join, and then we write using or on with the list of attributes for using or a predicate for on. Now, once we have joined on the join expression, we want to place our matches in the center of a Venn diagram. Then we want to put the left table rows that did not find a match on the left of the Venn diagram. Finally, we want to put the right table rows that did not find a match on the right of our Venn diagram. Here is a summary of what we want. Now, let's fill in the Venn diagram for practice and to use for our actual joins. Let's use the natural join condition. We have 3 matches, 1 on the ID of 1 and 2 matches on the ID of 2, so we place them all in the center, with their values filled in, and of course having the ID attributes merged into one column. Now, for the left table, called person, we had 1 row without a match on ID, so we place it on the left of the Venn diagram. We also had 1 row not matched on the right table, so we place it on the right of the Venn diagram. Notice that we still put in the attributes of the other table for the unmatched rows in our Venn diagram, but we put null in for them because obviously we can't really have a value for them. The first type of join is the inner join. The inner join just means we take all the rows inside the center of the Venn diagram. We can get this by using the code of from person natural join eats. Actually, we can say inner join instead of join in our code, but SQL is smart enough to work in both cases. Here is the result of that query for the inner join. Next, we have the left outer join. The left outer join takes the rows in the center of our Venn diagram and the rows in the left of our Venn diagram. Instead of just saying join here, you can see we say left join. We can say left outer join in our code if we would like, but writing the keyword outer in our SQL statement is not required. Here we can combine the 2 tables to get our query result. Next, we have the right outer join. The right outer join takes the rows in the center of our Venn diagram and the rows in the right of our Venn diagram. Instead of just saying join here, you can see we say right join. We can say right outer join in our code if we would like, but writing the keyword outer in our SQL statement is not required. Here we can combine the 2 tables to get our query result. In some SQL flavors, like SQLite, the right join is actually not supported. To mimic the behavior, just use a left join, but swap the order that you write the tables. You will get the same result as the right outer join would yield. Reinforce your learning on SQLGuild.com with practice questions, lessons, and a SQL code editor. Next, we have the full outer join. This just gives us everything in our Venn diagram. We can write full join here, or we can write full outer join if we would like to be especially specific. We can combine the 3 table here to get our result. Like the right join, the full outer join is not always supported. To mimic the behavior, first just write the left join, which I'll just replace with the words left join to save some space here. Then we want to union the right join. The only issue is that this gives us the stuff in the center of our Venn diagram twice. To remedy this, we add a where clause to say let's filter the right join to only have the values that have a null value for person ID. This basically just means give us the stuff from the right outer join without the stuff in the center, which can then be unioned with the left outer join to give us the full outer join. Let's dig a little deeper in this, since this concept is really important for our next type of join. In the center, we have an ID from the person table and the eats table, which have been joined, but are still accessible using either table prefix. On the other hand, for a row on the right, it has an eats ID of 4, but a null value for a person ID, because it was never joined with person, so of course it would not have an ID from the person table. Again, the code means, give us the left outer join, and also the right outer join, but the right outer join should only keep its values that do not have an ID from the left table, or in other words, were never joined with the left table. And so it is the stuff only on the very right of the Venn diagram. Next, we have the left anti-join. This is just the stuff on the very left. We follow the same logic as the full outer join. We say give us the stuff in the left outer join, but only if the ID from the right table is null. This is our result of the left anti-join. Then we have the right anti-join, which is really just the same thing, but vice versa. And there is our result. Now we have the left semi-join. The left semi-join is fairly simple. It is just where we keep all the rows in the left table that matched at least one row on the right. You can think of it more like a filter than a join if you want, but of course we are still basing a match on the join condition. In this case, only the first two rows had a match, so we just keep the first two rows. We can do it with this SQL query. Basically, the code just says, give me everything from the person table, which is the left table, where there exists a row from eats, which is our right table, that matches eats on the ID value. Now we have the right semi-join. The right semi-join is also fairly simple. It is just where we keep all the rows in the right table that matched at least one row on the left. You can think of it more like a filter than a join if you want, but of course we are still basing a match on the join condition. In this case, only the first three rows had a match, so we just kept the first three rows. We can do it with this SQL query. Basically, the code just says, give me everything from the eats table, which is our right table, where there exists a row from person, which is our left table, that matches eats on the ID value. Okay, finally we have the self-join. The self-join is just where we join a table on itself. This can be useful in certain cases. Here we have a table called player that has player ID values and a coach ID for their coach. We can join the tables on coach ID and player ID to get a list of players that are also coaches. If we actually try this, we will see we get two matches, where the player ID is equal to the coach ID, so there are two players in the player table that are also coaches. Now, let's understand the Equi-Join. Most joins are Equi-Joins. Equi-Joins are joins that only use a join condition based on having column values being equal. Here we have a natural join on two tables. We are joining based on if the ID attribute values are equal, so it is an Equi-Join. If we did a using join condition on ID, we would be joining based on the ID attribute being equal, so it would also be an Equi-Join. If we did a join with the on condition, based on if person ID is not equal to eats ID, then we would be joining based on the ID attribute being not equal, so it would not be an Equi-Join. If we did a join with the on condition, based on if person ID is greater than the eats ID, then we would be joining based on something other than equality, so it would not be an Equi-Join. But the on condition doesn't always mean that our join is not an Equi-Join. Here we can see that we have an Equi-Join that joins on equal ID values. Sometimes, we want to join two tables into one table. The simplest way to do this is to combine every row of the first table with every row of the second table, which is called the cross-join. Here we have a name table on the left and an age table on the right. Let's get the cross-join. First, we match the first row of name with the first row of age. We first insert data from the name row and then the age row. Next, we match the first row of name with the second row of age. We first insert data from the name row and then the age row. Next, we match the second row of name with the first row of age. We first insert data from the name row and then the age row. Finally, we match the second row of name with the second row of age. We first insert data from the name row and then the age row. We can do this with code in the from clause by writing name cross-join age or simply writing name comma age. Follow along these videos on SQLGuild.com. Thanks for watching the video. Like and subscribe. In the next video, we will work on some practice join questions from SQLGuild.com.